Everybody's trying to get to the next level, and somebody is getting to the next level.
Nvidia's new chip is so powerful that it can slash computing costs by a whopping 90%. Now the tech giants, who have been spending millions, are taking a U-turn. Before we expose why Rubin is causing absolute chaos in Silicon Valley, hit that subscribe button to stay up to date with the latest technological news.
Now, in the second half of this year, we'll easily transition into the upgrade.
Rubin chip. Let's start with what makes the new Rubin fundamentally unlike anything we've ever seen before. This is a complete architectural innovation of AI innovation that has reimagined how AI chips should work, and the numbers are quite frankly baffling. According to Nvidia's own specification, Rubin reduces the cost of the AI model up to 10 times compared to the previous generation chips. Just read that again. Up to 10 times cheaper for companies that are currently burning through hundreds of millions of dollars on their AI infrastructure. This is a godsend innovation that is going to make them save a lot of money. However, if you're a competitor, it could become a nightmare depending on which side of the equation you're on. The cost savings are only one part of the story because Rubin requires 4 times fewer GPUs for training the same exact models. That means that if we needed 1,000 chips before to work, now we will only need 250. This efficiency gain is huge, and some business analysts are calling it the biggest leap forward in the AI industry since GPUs first became viable for deep learning. This architecture itself is quite innovative. Rubin isn't just a single chip, as most people believe. It's a system of 6 different chips that are engineered to work as one unified processing unit. Let's understand what this chip actually is. First, Nvidia made what they call the Vera chip, which is a custom-designed processor that delivers double the performance of the previous generation. And the CEO of Nvidia, while describing this chip, was quite enthusiastic, something which not a lot of tech innovators have seen in the AI industry in the last few years. This custom-designed processor delivers double the performance of the previous generation.
In production by now, and so today I can tell you that Vera Rubin is in full production.
But then we have the Rubin GPU itself. And here's where things get interesting. Vera and Rubin were co-designed from the ground up to bidirectionally share data at a speed that was unimaginable, along with having the lowest latency possible. This is like older systems where the CPU and GPU communicated. This isn't like older systems where CPU and GPU were bottlenecking with each other, making the efficiency go down. These components were built specifically to work together, passing information back and forth in ways that completely abolish a traditional performance barrier. The result is a computing platform that can deliver 100 petaflops of AI performance, which is 5 times more than the fastest technology we have today. Let's take the example of what it means in practical terms. Let's say that you are training a large language model that used to take weeks or months to process and understand data. Now, the same training can be done in days, or even a couple of hours. Running inference on complex AI systems used to require entire server farms, and now they can happen on just a tiny fraction of the hardware. For the first time, we are looking at AI computing power that will actually outpace the industry's ability to utilize it fully.
This is the story of how we built it. The architecture, a system of 6 chips, engineered to work as one, born from extreme co-design. It begins with Vera, a custom-designed CPU, double the performance of the previous generation.
Industry in shock. And here, where things get spicy, you might be wondering why the biggest players in the tech world are absolutely cooked or terrified of what the Rubin represents. For years, whenever there's a unique technology that makes it to the world, other big companies like Apple, Google, and even Amazon usually make their own version of that technology. For now, these companies have collectively spent hundreds of billions of dollars building their own AI infrastructure. They have invested in massive data centers, purchased millions of GPUs, RAMs, and even designed their entire cloud computing strategies around the capabilities and limitations of the current chip architecture. Then comes Rubin, who threatens to make huge portions of that investment completely irrelevant almost overnight. Imagine being CTO of a company, realizing that the $50 billion that you just spent on your latest AI infrastructure, trying to make it more efficient, could have been $5 billion if you just waited one more year. This is not even hypotheticals that we are talking about. This is actual math that is keeping these executives up at night. Even Deutsche Bank recently estimated that OpenAI alone could burn through $143 billion between 2024 and 2029 before reaching profitability. This is all thanks to Nvidia and its innovations. The estimate was based on current chip cost and efficiency levels. If Rubin delivers even half of what Nvidia promises, those projections would also become meaningless. OpenAI could potentially cut its infrastructure spending by 60–70% just by increasing its computing capacity. But here's the thing. All of this new chip talk has been causing so much chaos. Lower cost should theoretically mean less revenue for Nvidia, too, right? Except that's not really how technology adoption works. When you make something dramatically more efficient, the total consumption actually increases rather than decreases. Let's take the example of what happened with cloud computing when AWS was first launched. Storage and computing became much cheaper, but did the company spend less overall? Of course not. They just started building applications and services that would have been economically impossible before because they just didn't exist. The total market explodes. Instead of us buying the traditional, cheaper storage, we are stuck in this cycle of subscriptions and paying for storage monthly and even yearly. The same dynamic is about to play out with AI as well. When you run AI models for 90% less money, suddenly thousands of use cases that weren't viable before come to life. Companies that weren't planning to adopt AI would now go all in. The entire user base increases to a level that was not possible before. A lot of companies are already planning to deploy Rubin in their services, such as Amazon Web Services, Microsoft Azure, Google Cloud, and others. Planning to adopt Rubin in the second half of 2026. AI leaders, including OpenAI, Meta, Anthropic, and others, are also planning to use it for their next-generation models. In other words, Nvidia has made something that is virtually impossible to ignore, even for the biggest players in the game.
And the Rubin GPU. Vera and Rubin are co-designed from the start to bidirectionally and coherently share data faster and with lower latency.
CUDA getting deeper. But what makes the Rubin chip so great? It isn't actually the hardware, but it's CUDA. For those who don't live in the tech world, CUDA is Nvidia's proprietary software platform that allows developers to write code that can actually run on Nvidia GPUs. Hundreds of thousands of developers worldwide have been trained on CUDA. Each university science program teaches it, and every major AI framework like PyTorch, TensorFlow, and others are optimized for it. This creates what investors call the switching costs. But that term doesn't really capture the magnitude of what's about to come. We're talking about workflows, debugging tools, and even performance profiling systems, along with deployment pipelines that are all built around Nvidia's ecosystem. Even if a competitor, let's say Intel, decides to release a chip that's technically superior or even cheaper than Nvidia's Vera chip, the cost of switching to that system would be astronomical. Not only will they need a newer set of engineers, but everyone is so deeply stuck into Nvidia that they will need to rewrite massive portions of their codebase, rebuilding and retooling their infrastructure, and even accept months or years of degraded productivity while everyone gets up to speed. Most companies simply won't take the risk because it's just too high. So, what happens now? Nvidia releases the Rubin, which is built on the same CUDA foundation, and suddenly upgrading is trivial. Your existing code works, and developers already know how to optimize for it. You can just swap the hardware and immediately get massive boosts in productivity. Rubin makes this even deeper because it's not just faster, but it enables entirely new types of AI applications that weren't even possible before. If Rubin can capture around 50% to 70% of the high-end AI chip market through 2028, which seems quite conservative given Nvidia's 90% market share in this industry, we are looking at potentially $150 billion to $200 billion in gross profit over that period. Moreover, after the operating cost, this translates to around $120 billion to $160 billion in overall net income. These are numbers that rival the total worth of most S&P 500 companies. Focus on China. If you thought the craziness ended here, it doesn't. It only gets more interesting from here. Now, we need to talk about the geopolitical wildcard that could make Nvidia's growth astronomical: China. On the 13th of January 2025, the Trump administration approved exports of Nvidia's H200 chips to China, reversing the previous restriction that had locked Nvidia out of one of the world's largest markets. This response was huge. Chinese tech companies ordered more than 2 million H200 chips at approximately $27,000 each. Let's do the math real quickly. This is around $54 billion in potential orders. That's almost an entire year's worth of revenue that is compressed into a single market opportunity. However, there are some restrictions. The U.S. is taking a 25% licensing fee, so Nvidia nets about $20,000 per chip, which is still a lot. China can't even purchase more than 50% of what Nvidia sells to U.S. customers, and all buyers must also agree to security requirements and non-military usage terms. Even with those limitations, we are still looking at around $40.5 billion in potential revenue. And here's the important thing: there are real risks here. Beijing has been applying pressure on domestic companies to prioritize Chinese-made chips whenever possible. Some reports even indicate customs delays and regulatory friction that could slow down or reduce those shipments. We can see that there might be around 20 to 30% of initial orders approved, which would mean $8 to $12 billion in revenue and roughly $5 to $8 billion in additional net income. But the wild card is what happens with Rubin. If Chinese companies get access to the Rubin chip, which is unclear given the plethora of regulations that America has put in place, the demand could become even more explosive. This efficiency would be quite valuable in China, where energy costs and data centers are quite a huge limit. But it could also cause a huge tech war between the world's largest economies, which are China and America.
Then, 17,000 components come together on a Vera Rubin compute board. High-speed robots place components with micron precision before the Vera CPU and 2 Rubin GPUs complete the assembly.
Unique aspects. Some of the technical details on what makes the Rubin chip so revolutionary from an engineering standpoint, because once you understand, it becomes wilder. A complete Rubin system tray contains no cables, no hoses, and not even a fan. Think about this for a second. When we have high-performance computing systems of the current generation, they're filled with cables like spaghetti. Each computing tray includes a blue field for DPU, which is a data processing unit. 8. Connect X9 network adapters, 2 Vera CPU, and 4 Rubin GPUs. The DPU is crucial here because it offloads the storage operations and security functions, ensuring that the main compute resources stay at 100% focus on workload AI instead of getting distracted. For scaling out to thousands of GPUs across multiple racks, which is what you need for training frontier AI models, Nvidia even developed Spectrum X Ethernet with integrated photonics. It is the world's first Ethernet switch, with 512 lanes of 200 gigabytes per second co-packaged optics. This Rubin rack contains 220 trillion transistors and weighs nearly 2 tons. Nvidia says it took 15,000 years for engineers to design and build. This level of complexity and integration is something only Nvidia could make. And thanks to their new systems, even the biggest companies in the world are terrified, with their stakeholders unable to sleep on what they should be doing next. Do you think all the big tech companies are cooked? Let us know in the comments down below, and subscribe, because we are diving deep into AI wars that you don't want to miss.